ratings. This is the group project of electrical by the group 10 is about the experiment of permanent magnetic DC motor. So this is the component that we use in this experiment. They have two type batteries. It is two batteries of 1.5 voltage and one battery of 9 voltage, battery holder, copper wire, magnets, erasers, paper clips, digital multimeter, connection wires, and screw source. So for the procedure, first one, we bend the paper clips to make the support for the copper wire just like the picture one. And then we wrap the copper wire roughly 10 times around a cylinder such as use a pen with a cylinder to form a compact loop. Leave approximately 2 centimeters of straight wire on both ends sticking directly outward just like the picture 2. Then we lay the cord flat on the table and use a screw source to scrape away the copper wire insulation completely around the circumference of one straight end. On the opposite straight end, we scrape the insulation off on only the top half of the wire. Then we stick the paperclip to the eraser to make. Ensure the loops at the top line up evenly so the coil can spin easily. Then we place the magnet directly on right beneath where the coil will sit. We rest the square extensions of the copper coil inside the support lobes just like the picture that we show. Then we insert two 1.5 voltage batteries into the battery holder and then connect them to the paper clips on both sides, and the picture have shown that. And then we gently flick the coil to initiate the rotation and use the digital multimeter to measure the current for 10 turn coil and double 1.5 batteries. Then the next two video will show about that the final product and that how we use the multimeter to measure and get the data.
Cerita. Balik. Hati. Lelok.
Ini yang kita kena buat. Ini ada. Semua sama je.
Ya.
Ini baru cerita tu.
Tu kasih test tu.
Lepas tu multimeter buat apa?
Nak ambil dia punya current. Basically kita kena buat eksperimen, ambil dia punya current dan juga dia punya speed. RPM. Jebol. Okay, have one.
Lastly, we wrap the copper wire roundly with different times, that is 10 times, 30 times, and 50 times. And we use the different batteries such as double 1.5 voltage batteries and one batteries of 9 voltage. Then we record the data in the table. So below is the table and the data that we collect. So our group have draw the true graph. The left one graph is the speed graph and the right one is the current graph. Based on the speed graph, the 15 turn coil achieved the highest rotational speed among all configurations. It reached 1500 RPM at 3 voltage and remained close to this value at the 9 voltage. The 13 turn coil showed the moderate performance while the 10 turn coil recorded the lower speed at around the 1000 RPM. This indicates that increasing the number of coil turns strengthens the magnetic field and improves the motor speed. For the current graph increased when the voltage was raised from 3 voltage to 9 voltage for all coil configurations. However, coils with a higher number of turns consume less current. At 9 voltage, the 10 turn coil drew the highest current of 0.6 ampere, while the 50 turn coil used the lowest current of 0.43 ampere. This is due to the higher resistance of the longer coil wire. So overall, the 50 turn coil showed the best performance because it produced the highest speed while consuming the lowest current. Therefore, it is the most efficient PMDC motor configuration among the design tests. So this is all our presentation. Thank you for your watching.